Hello future engineers and my dear students, welcome back to Mudassir Academy. I am Mudassir Sir. Today we are going to start with a very easy yet very important and compulsory question that is repeatedly asked in the VTU examination from linear algebra, and that is the Rayleigh Power Method, or simply called the Power Method, which is used to find the highest or the largest eigenvalue and its corresponding largest eigenvector. Now listen carefully. Rayleigh's Power Method is one of the simplest methods in numerical linear algebra. But I've seen many students spending 30 to 45 minutes or more than that solving one problem in this method. But you don't take stress. With the shortcut techniques and the structured approach I'm going to teach you, you'll be able to solve the question in just 5 to 6 minutes. Yes, only 5 to 6 minutes. Don't worry. See, I'm not going to do it in 5 to 6 minutes here. I'll show slowly how to solve the method. But remember, the speed and accuracy will come only with practice. And there is no need to do lengthy manual calculations. I will show you to do almost everything using a scientific calculator. So please do not watch the video passively and assume that you'll do it later. See, this won't help at all. Okay, so follow with me, write every step neatly, use a calculator and solve with me step by step. If you follow, you will succeed, guaranteed. So let's understand how to apply the Rayleigh's Power Method or the Power Method using this classical problem. So it says, find the dominant eigenvalue and the corresponding eigenvector of the matrix A is equal to 6 minus 2, 2, minus 2, 3, minus 1, 2, minus 1, 3 by Power Method, taking initial eigenvector as 1, 1, 1 transpose. See, sometimes instead of this dash, they may give T also. Both are same, transpose. Okay, why? Because see, they written like this. Okay, why? Because the eigenvector is always a column vector. Getting it? Is always a column vector. If I remove this transpose, it will become, it will stand up. That's it. It will become a column. So I show it in the problem here. Okay, fine. Now one more thing, listen to me carefully. See, here they have given initial eigenvector as 1, 1, 1. That is, here they given, right here, they given initial eigenvector x0, I'll take it as 1, 1, 1 transpose. They already given. Okay, if they won't give, then what? See, always in the theory of the Rayleigh's Power Method says that if they have not given any initial eigenvector, assume it to be 1, 0, 0. That's it. Okay, so I write here, if not mentioned, I write here, if x0 not given, then you have to assume, x0 is equal to 1, 0, 0 dash or transpose. That's it. Since they are given here, I will take here x0 is equal to 1, 1, 1 dash. That is initial eigenvector. So initial, okay, eigenvector is given as x0 is equal to 1, 1, 1 dash from the question. If they don't mention it, if they not given the question, then you have to take 1, 0, 0. Simple as that. Okay, so we'll solve this question now. Now, the simplest way of solving this problem is, but I request you to, get ready with your notebook and calculator, as I said, because the accuracy and the speed will come only by practice, nothing more than that. Fine? Okay, simply don't scroll it, keep on scrolling, it's so easy and leave it. It won't help at all. I'm 100% I'm guaranteeing you, if you scroll it ahead, you won't get it. Correct? And one more thing, see, please excuse me for the delay in uploading the videos. Okay, I am currently undergoing a treatment for cancer, and some days are challenging, but I promise you that I will continue to upload as fast as possible before the examination, so that you can prepare well and score high in examinations. And your support means a lot to me. If you are new, please do subscribe to my channel, share with your friends and classmates as much as possible, and help me grow this platform so I can continue helping engineering students like you. So thank you for your patience, prayers and encouragement. So now let's move ahead with solving this problem here. So I hope you are ready with your pen, your notebook and your calculators. So first thing, the method is very simple. Understand here what to do. We simply do, they have given already x0. They again 1, 1, 1 transpose. If no, then take 1, 0, 0. Since they given here, First what we'll do, we'll multiply. So A into x naught is equal to, write it neatly. What is A? A is 6 minus 2, 2, minus 2, 3, minus 1, 2 minus 1, 3, into. Now see, as I told you, the eigenvector is always a column vector. So in multiplying here, when I remove this transpose, it stands like this. 1, 1, 1. That's it. Now, I hope you are ready with your notebook, pen and calculator. So use a calculator totally. Will not do anything. We'll simply make the scientific calculator to get a full answer correctly. Okay. So I'll use here FX991 CNW. Later no, the same steps I'll show using FX991 ES plus. But because I know you people have both this calculator and both functions are different. Well, now again, as always I do, reset a calculator. We go to home, on, home, press and calculate, then go to settings, reset, initialize all. Yes, done. Okay. Now we are calculating matrices here. So which mode? Go to table equation, then we have matrix. Yeah, matrix. Fine. Then they ask you to press tools here. Press tools. Okay. Mat A. How many rows? 3 rows, 3 columns. So write it. Okay. So 3 rows and 3 rows, and how many columns? 3 columns. Fine. Confirm. Now they are asking to enter the matrix here, step by step. So have patience. Okay. Take down the question properly here on the calculator. If you go in mistake, do mistake while taking down any numerical value or sign, then go. Please be careful. So I'll enter all the values here. 6, execute minus 2, execute 2, execute minus 2, execute 3, execute minus 1, execute 2, execute minus 1, execute 3. Done. So verify again, because this is this value what enter for matrix A will be remaining till you get the entire solution, the same as it is. Okay. So 6 minus 2, 2, minus 2, 3, minus 1, 2 minus 1 and 3. Fine. Now AC. Again press tools. Again we go to matrix B. Okay. So how many rows? See, 1, 2, 3 rows and 1 column matrix. So we have 3 rows and column is 1. Fine. Confirm. So it's given as 1, execute 1, execute 1. AC. Okay. Now we need to multiply it. Again, you go to what you need to go? Again, go to catalog, go to matrix. Here you'll find matrix here, catalog, then matrix, then see, go to matrix A into, simple sign into, again catalog, again matrix into, go down matrix B. Matrix B, execute. So you're getting 604 at right here. 604. Now the interesting part. See, which is the highest number here? 6. Simply do nothing, divide by 6. So better take 6 outside. See, I'm doing systematic need step by step. Take 6 outside, and here what you do, divide by 6, execute. So I get it as 1, 0, 0.66. I take 0.667. That's all. Okay. Now what I'm getting here is my eigenvalue. 6 is the eigenvalue and this is the eigenvector. So this is my new eigenvalue at right here only lambda 1, and this is what? x1 I take. Initially was x0, now x0 becomes 1, 0, 0.667. Fine. Now again, okay, what I'll do, same thing, I will multiply again a into x1. Again a into x1 means 6 minus 2, 2, minus 2, 3, minus 1, 2, minus 1, 3 as it is. What is x1 here now? New eigenvector 1, 0, 0.667. You keep on iterating it. Till when? I will explain you. So keep on watching. So now again, now see, when in calculator, no, there is again no, see what I see is again people know they take this matrix, again enter this matrix 1, 0, again multiply. It's not required because You're using the scientific calculator. Everything is given here. Only you need to work smartly. That's all. Okay, and I'm going to teach you that. Now, see, I got this. The moment you press execute or equal to, okay, when I divide by and press execute, this whole thing 100.66 gets stored where? In mat answer or matrix answer. Okay, so I show you how to use that. Now see, again, I don't touch anything, everything is here. Again press AC. Again go to catalog, again matrix. Now again what I am going to do here, matrix A into matrix answer. I write here for you. So mat A into matrix answer. That's it. What I am going to do here. That means mat A into again catalog matrix, go down, you'll get mat ans. Simply execute. That's it. So we get the values as what? 7.333. Okay, this will be new values are 7.333, then minus 2.666, and lastly 4. So the same step repeats, which is the highest number here, numerical value 7.333. Okay, that is, take it outside 7.333, and what I'm going to do, divide this whole what I obtained by 7.333. So simply press divide by 7.333 is equal to, so we get here 1 minus 0.363 and 0.5454. Okay, now again say this is my new eigenvalue lambda 2 and this is my new eigenvector x2. That's it. Okay, again when I press, as told, I'm going to press execute here, this value gets stored in mat answer. So again simply do nothing. Again matrix A into mat answer. Keep on repeating this circus. That's it till you get the answer. I'll show you where to do it. Again A into x2 equals 6 minus 2, 2, minus 2, 3, minus 1, 2, minus 1, 3, into 1 minus 0.363 and 0.5454. Okay, so this yields again same AC, press catalog, matrix, then down matrix A into again catalog, matrix, scroll down, we get mat answer, execute 7.8185. So 7.8185, then minus 3.636, and lastly 4.0001. 4.0001. Now again, which is the highest value here? 7.8185. So divide by 7.8185. Execute. Again we get 7.8185 outside. Since I'm dividing it, then 1 minus 0.465 and 0.5116. Okay, so this is my new eigenvalue lambda 3 and new eigenvector x3. That's it. Fine. So let's again repeat the same circus or same iteration. Again, A into x3 is equal to, what's that? A into x3, 6 minus 2, 2, again minus 2, 3, minus 1, 2, minus 1, 3. Okay, into, again we have 1 minus 0.465 and 0.5116. So again, you see catalog matrix, matrix A into catalog matrix, scroll down, matrix ans is equal to 7.9535. So 7.9535 minus 3.906 and lastly 4. Okay. So this will be again, what is the highest numeric value here? See, one more thing I'll tell you. I was solving one more problem, so please stay updated. See, the highest number is to be taken, not a sign. See, if this was minus 7.9535, then also you have to take 7.9535 only outside and minus, keep it inside, whatever, minus 1. Getting the point? Correct? See, because see, if it was minus 7.9535 and this was only plus 3.906, then you will say that 3.906 is higher. No, eigenvalue, take the highest number outside, not its sign. Getting it now? And again, if this was minus 7 point, take 7.9535 outside and keep the minus sign inside. That's it. So we see it in the further problems. Okay, so please stay updated. Now, who is highest here? 7.9535. So divide by 7.9535 is equal to, again, 7.9535. 1 minus 0.491 and 0.5029. This is what we get. Okay. So it was how much? 0.491. Perfect. So again, this is my new eigenvalue and this is my new eigenvector x4. So one more iteration now we are going to do. So again, we will do here what? A into x4. Okay, right here. So we have again A into x4 is equal to, again, 6 minus 2, 2, 6 minus 2, 2, then minus 2, 3, minus 1, and 2 minus 1, 3. Into, what do we have here? 1 minus 0.491 and 0.5029. Again, this will be catalog matrix A into catalog matrix catalog matrix, and we go to matrix answer. Then is equal to, see, 7.9883. So what I'll do, I'll take outside 7.9883 into, sorry, the highest number is 7.9883, then minus 3.976 and 4 I getting. So since there is less space here, what I'll do, I directly divide here. So divide by 7.9, divide by 7.9883 is equal to, so we get 1 minus 0.497 and 0.5007. Yeah, see, we are getting a new eigenvalue here, which is lambda 4, now it is lambda 5, and new eigenvector x5. Again, let's repeat. I will show you slowly where to stop. Again, A into x5 equals to 6 minus 2, 2, minus 2, 3, minus 1, 2, minus 1, 3, into again 1 minus 0.497 and 0.5007. Please verify your values also. Okay. Now, this will be again AC catalog matrix A into catalog matrix answer, execute. We are getting here 7.9971. I write here this one, 7.9971, then minus 3.994 and lastly 4. So the highest value is 7.9971. So let's divide by that. So divide by 7.9971 is equal to, so 1 minus 0.499 and 0.5001. Yeah, so we are getting our new eigenvalue and eigenvector. Okay, this is lambda 6 and x6. So we can stop here. Why I am telling you, see. Now, these are called iterations. Raylaigh's Power Method is also called iteration method. Same steps you keep on repeating, and we check the final two steps. The value should approximately match. See, x4, 7.933, 7.9. So what I'll do is do one more step to make it clear. Okay. So again, a into. See, initially, a minimum 5 to 6 steps are required. Okay, some problems end in 4 steps also. So minimum 5 is required because the question they ask for around 7 marks. So please do 5 steps. Okay, because the answer should be exact. Now again, 6 minus 2, 2, minus 2, 3, minus 1, 2 minus 1, 3, into again 1 minus 0.499 and 0.5001 equals to, again same circus. We do catalog matrix A into catalog matrix, go down, yeah, matrix answer, execute. See, 7.9926, 7.9926, then minus 3.998 and 4. Okay, so now again the highest value is 7.9926. So divide by 7.9926 is equal to, so 7.9926 divided by 1 minus 0.5 and we have 0.5004. This is what my calculator is claiming. Okay, so this I have here my final eigenvalue and the eigenvector. This, as I told, is called iterations. Okay, so now see here carefully. If you see here, see, the value should approximately match 7.99. See, 7.99. Same. See, 1, 0.499, 0.5, approximately same. 0.500, 0.5 same. So you stop here. That's it. When the last two iteration match, the values of both the lambda eigenvalues and eigenvectors match, you stop. That's it. And minimum, once again, 5 to 6 iterations are required. Minimum 5 is required. Okay. Now we have it here. Therefore, seeing the last ending here, we have this. We take this one and this one. Therefore, we'll write here lambda equals to 7.9926. That is approximately equal to what? 8. And the eigenvector, okay, x is equal to, it is, what is that? 1 minus 0.5 comma 0.5004. Now I'll complete the answer. Therefore, by the Rayleigh's Power Method, the dominant eigenvalue or the highest eigenvalue, all right, dominant eigenvalue lambda equals to, what is that? 8. Correct. And the eigenvector and dominant eigenvector x equals to 1 minus 0.5 and plus 0.5 transpose or t. That's all. This is the answer. Beautiful. So I'll underline this. Dominant eigenvalue is lambda is equal to 8 and dominant eigenvector is x is equal to 1 minus 0.5, 0.5. You so Eigen Vector, you can multiply by any scalar. If you multiply by 2 side, become 2 minus 1 and 1. You can do that. This is enough. Okay. So this is how we do it. So I showed you step by step everything is in a calculator. But again, accuracy and the fastness and the speed will only come by practice, practice and practice. That's all. So when you start solving the same question 2-3 times, you get a hands on a calculator. Okay, then your brain and the fingers and the calculator will give you the answers here. So everything will be 100% perfect. Okay, so we are solved using the FX 991 but many students, like the older semesters or some people, they have this FS 991 yes plus also. I don't want them to be left behind. I show the same step here. Fine. First thing, and first we reset the calculator. So we go to shift clear 3 all is equal to, fine. Now you see, now the matrix is moved. Go to 6 matrix. Don't enter any 1, 2, 3 here. Just simply press AC, because entering the mode here, we have to go to shear. Above that, above this keypad number 4, there is matrix written. So to enter that, above that, you go to shift matrix. So dimension matrix A 3 by 3. So enter the matrix. 6 equals minus 2 equals 2 equals minus 2 equals 3 equals minus 1 equals 2 equals minus 1 equals 3. Done. Again AC. Now we have to enter the matrix B here. So shift matrix dimension number 2 matrix B, 3 rows 1 column. So 1 equals 1 equals 1 equals. Done. Now the operation again, see, shift matrix 3A into shift matrix B is 4 equals 604, same as it is. Okay, so what was highest number? 6. So divide by 6 equal to 0.667. Again, see, I repeat you, if it was says minus 6, then don't take 4 as a higher number. Take 6 only. Take 6 outside, let the minus sign remain inside. Those such type of problems I will be discussing further. So now you just practice this. Fine. Now again, see, when I press divide by 6, we get this much, and this gets stored in mat answer. See here again, AC, shift matrix A into again shift matrix number 6 mat answer is equal to 7.333 minus 2.664. Perfect. Now again, who's the highest number? 7.333 divided by 7.333 is equal to again 0.363, 0.5. Perfect. Again, the same circus repeats. What? Mat A into answer, mat A into answer, mat A into answer. Till you get this. Okay, let me do one more time for you. So again, see, shift mat A into again shift mat answer 6 is equal to again 7.8185. So divide by 7.8185 is equal to 0.465, 0.566. Again, one more time. Last time I'll do, because everything is same, the process same. Matrix. So matrix A into again shift matrix 6 is equal to. So divide by 7.9535 is equal to 1, 0 minus 0.491, 0.5029. Extra everything remains the same. Okay. I hope you clearly understood the use of both the 991 CLW and this 991 yes plus. Okay. So only trick here is what practice and practice and practice. That's all. So practice this once, twice, then automatically what will happen? Your mind, the fingers and the calculator buttons will coordinate, and you get 100% right answer guaranteed. So I have done my work. I made it very, very easy. Now it's your time to practice and make more perfect and score the full marks in your examination. That's all. So that's all for today's video. So please stay updated. Please, if you have any doubts here, or if you want me to solve any other problem, please do comment in the comment section below. Share this video with your friends and classmates as much as possible. Okay, be confident, practice more. Happy engineering. Bye.